I mean, if he's talking about 2 psi as being the difference between the outside environment of space and the suit, first of all, how does anybody survive under 2 psi? Humans are not designed for it. They can't survive at 2 psi.
No, the suits are rated so-called at 3.7. The failure is NASA fails to account for the differential, which of their official document is another 14.7 psi of differential. So if you add the 3.7 to that, now you've got, 18.5 psi that they're dealing with in the suit. Now that's a problem.
Yeah, it is.
As you're getting up, it's a car tire at that point. Official basketball, I think, is 9 psi. And when it bounces, it rings, and you can't squeeze a basketball. If you could squeeze one flat, then you could operate the gloves in space. But when these people say, what's the problem? It's only 2 psi. They're not disrespecting us. They're disrespecting NASA for not being able to figure out how to deal with 2 psi.
Exactly. Come on, guys, you've got to think these things through. You can't just go on wittering on about what you believe to be the case until you've looked at the real facts of the case. If you've got an atmosphere where there is no air pressure at all, it's called, guess what? A vacuum, because there's no air pressure. Humans need air pressure, us humans. Unmanned craft, they don't need it. That's quite different. And this is the crux of the whole argument. Yes, you can get unmanned craft to the moon, and that's been done by a lot of people. China's done it, India's done it, Russia's done it, America's done it. That's never questioned. Unmanned craft don't need to deal with the vacuum of space in the same way that humans do. Humans need to have pressure. If we didn't have pressure, we'd go pop and explode. So you've got to deal with that. And the difference between unmanned craft or artificial material, such as metals, aluminium, steel, carbon, everything else, that doesn't need pressure. Humans, us lot, we need pressure. And if we haven't got it, we got a problem. Not for long, because we'll be dead, but we need pressure.
Yeah, except the problem is you get down to a certain vacuum level, and then those metals have a problem with the vacuum because they start cold welding, they start off-gassing.
Exactly, yes.
Right? And for that effect to happen, like, it creates an anomaly with the materials that allow them to off-gas out of there that doesn't happen under normal air pressure, or happens at such a slow rate under normal air pressure that we don't notice it, like it could be thousands of years. An inanimate object is still affected by the vacuum. It can withstand higher temperatures and temperature ranges. It can withstand any amount of radiation if you get enough shielding on it to protect the electronic equipment, but it's going to weigh a lot, and it's still going to break down. You can rate it for a certain amount, and solar mass ejection from the sun will come out and simply wipe that out. So space, even for a satellite or whatever, is not a stable environment. And people have to understand that as well.
Exactly. But satellites can be protected against the known dangers of space. The vacuum and the radiation, they can be protected. In technical terms, it's called hardening. And they can be hardened using particular materials, lead being the popular one, against radiation.
I forget what document I was reading, and the Van Allen belts are equivalent, I think, to 9 meters of lead. You're looking at 40,000 kilometers of the belt in there, and they are protecting the Earth equivalent to 9 meters of lead. That's just unbelievable. So how much lead, if you put a couple of inches on, that will protect you below the Van Allen belts? When you're in them, you've got to have a hell of a lot more. But when you're outside of the Van Allen belts, how much radiation is there? We've never got an accurate number on what variances, because you're getting radiation. Cosmic radiation is coming in from all directions as well. And gamma rays, everything else are coming in there. How much protection do you have to have a vehicle beyond the Van Allen belts? There aren't any accurate measurements on what's happening out there. And it's going to be completely variable depending on what the sun is doing. And those are the numbers that nobody gets to see, because I've looked for those numbers. And if the Van Allen belts are that much of a protection to the Earth, and we're playing below it and still having a problem, anything that's within the belts or anything beyond the belts is going to be an incredible problem. So even standing on the lunar surface, or even putting a probe on the lunar surface, is going to get the full effect without the protection of the Van Allen belts. Those materials are going to break down very, very rapidly. I know people have different beliefs, but if they have put a probe on the lunar surface, how long is it going to be active for? And with that much interference between us and that, how can you communicate with it? That's a hell of a lot of interference for a radio signal.
It's something that doesn't seem to be addressed very much. He talks about the Van Allen radiation belts as being this great barrier to space, and we've got to protect. But Van Allen belts are only a small part of the problems of radiation in space. As you've already said, solar particle events, SPEs, galactic cosmic rays from deep space, gamma rays, X-rays. And as Professor James Van Allen said when he identified the belts as being real, he'd only theorized them before 1958 when he was able to send his Geiger counter up on Explorer 1. He said, this will cause a problem for human space travel. And then when he confirmed the level of radiation, when his second Geiger counter was sent up on Explorer 4, his reaction was space is radioactive. Humans don't like radioactivity. We tend to get affected by it. So humans have to be protected. And he suggested that the best way to avoid these belts, which are quite heavy areas of radiation, held in place by the Earth's magnetic field. And guess what? The moon doesn't have a magnetic field, so it doesn't have any radiation belts. It's unprotected.
It's been more than 10 years since they sent probes up to do any mapping of the belts. 2012 to 2014, they had the Van Allen probes up there to do the mapping of it. But you look at what has happened in NASA since then. They haven't been launching anything.
No, they haven't.
They basically shut down. They're defunct as far as space travel goes of any kind. They might launch a few things into low Earth orbit every now and again, but everything just seemed to stop right there. The documents they put out on the impenetrable barrier at 7,000 miles, obviously there's something there within the belts that is protecting the Earth. When you see any of the maps they draw around it, how the Earth is traveling through space and the radiation is hitting the belts and flowing around it, protecting it. There's going to be a concentration right in that area where it's actually being blocked and being pulled around. But that radiation is coming from space. So it's out there. If you go past the belts, it's going to be there and you don't have the belts to protect you. You're subject to it. It's going to be impacting you at the speed of light, like a CME coming off of there. The rays, the first set of X flares that they call it, coming off of there are going to reach you at the speed of light. You will have no warning whatsoever if you're traveling out there. You're just going to be hit. It'll just take that equipment off that craft, but it'll take you out at the same time.
This is the point I think we make continuously, is that once it is agreed and admitted and faced up to that Apollo was faked for political reasons, perfectly good political reasons, one could say, once we accept that that happened, that Apollo was not real and that no human has traveled beyond low Earth orbit, about 300 to 400 miles maximum above the Earth's surface, then we can get to the point where scientists around the world can start looking at the reality of what space consists of and how to protect humans in space. But for the moment, we have this ridiculous idea that 24 humans on the Apollo program, 3 of them went twice, Gene Cernan, John Young and Jim Lovell, went twice beyond Earth orbit and traveled to the moon. Once we get over that fact that it didn't happen, we can now get the world's intelligence, and there's plenty of intelligent people who understand these problems, and to get humans protected, because it would be great to have humans land on the moon. It would be fantastic. I thought it had happened until I found out I was being lied to. Once we get the scientists of the world cooperating in an open environment without fear of being ridiculed, they will probably solve the problem within a few years. When I asked a scientist who did investigate radiation, how were humans protected on the Apollo program from the radiation you've been describing? And you know what their answer was? This is a scientific answer, by the way. It was the luck of Apollo.
Amazing.
I mean, if you're going to rely on luck, then put all your money on a horse and see how far that goes.
Yeah, well, the luck of Apollo has been a nice fantasy for the last 50 plus odd years. I just pulled this down.
Oh, what's that book?
Chris Hadfield, The Apollo Murders. I don't know what it's about. There's the front. There's the back of it.
Let's have a look. What does it say?
It's a story of Apollo 18, the secret mission.
Oh, right. Okay.
a book of fantasy written by Commander Chris Hadfield. Maybe everything he's been saying his entire life has been fantasy. Part of his Canadian heritage of being our prized spaceman. He's our Neil Armstrong, I guess you could call him, right? Chris Hadfield. And then you realize that he's singing a David Bowie song and all of that stuff. And now he's writing a book on fiction on Apollo 18. He knows what's going on.
Yeah, I mean, maybe he's being honest about it. Maybe he's actually trying to show people.
No, I don't think so. He's been defending space travel even for the ISS. His son actually has a full-time job defending Chris.
Maybe travel to the space station. That's probably quite real.
But you see, if the son is being told that it happened, because Chris isn't standing out defending himself, he gets his son to do it, but his son never went to space. So as long as he believes it, but Chris knows the difference. He knows if he's in a simulator. He knows if he went to Felix and Paul Studios to do the simulations.
And he probably knows quite a lot about Apollo, even though he wasn't part of it.
I'm quite sure that given the limited amount of space travel that he knows that humans are capable of, like how far they can fly up, if it's 50, 60, 70 miles that they fly up there for a couple of days in orbit and come back down on the space shuttle. That's my opinion. I don't believe that anything is like that. They're not crossing the Karman line at any point in time because they don't have to. They can orbit for a few days without that and do whatever video simulation they need to do. The ISS, I believe, is a nice machine where they can go up and attach equipment to it to do studies and go up, pick it up, and bring it back. And that's what we have the Canada Space Arm, so it can pull it out, attach it, and bring it back down again.
They could do it.
Yeah. At that height, that solves the problem of the extreme vacuum, because you're not physically in space. You're still below the Karman line at that point. It solves the radiation problem. It solves the re-entry problem with the heat shields, even though at that speed, it's incredibly dangerous because we've seen it. And it'll still pull apart. You're still putting out thousands of degrees on the re-entry, even at that level.
Re-entry is a very dangerous thing. It's like how people describe air travel in airplanes. 2 times of extreme action and extreme danger, takeoff and landing. Same with orbiting. Orbiting is straightforward. Let's discuss Theodore von Karman, who was the originator of the famous Karman line, Karman. He was a Hungarian scientist employed by NASA in the late 1950s, and he decided that it was necessary to delineate space. Where does space start? Well, space actually starts, when there's no atmosphere, about 50 miles above the Earth's surface. Theodore von Karman decided he would make it a much more memorable number and say it was 100 kilometers above the Earth's surface. Everybody could remember 100 kilometers, which is 62 miles. Space actually starts slightly lower than that. So if you get to the Karman line, as the X-15 planes occasionally did, Neil Armstrong was one of the pilots who did it, you can claim to have been an astronaut, i.e. you can claim to have been in space because you exceeded the Karman line. The problem with doing it, even in the X-15, which is a rocket plane rather than a jet-propelled plane, was that the surfaces which you control the attitude and positioning of the plane wouldn't work in space because there's no air for them to push against, the air surfaces. So you exceed the 50-mile limit, it's about 275,000 feet above the Earth's surface. You're going to have a problem. So you've got to get back into the atmosphere quite fast or you're going to lose control. And
that's interesting that you're talking about Neil and he lost control because of the lack of air. And the fastest the X-15 flew was done at 100,000 feet. What's interesting on that is if you have a vehicle that there isn't enough air passing over the wing to have control of the wing, then how can you also look out at the wingtips and see them glowing red because of the friction of the air? Those are 2 separate events because one's high enough that you don't have any friction to control the plane with. And I'm quite sure that as he got lower down into the atmosphere, that the wingtips started to glow red, and that's when he'd be starting to have control of the vehicle again. But when I was reading the document, it's just like, oh, he's looking, the wingtips that are glowing red, and then he lost control. Well, no, that's not how it would have happened. The 2 things don't match. You either have enough friction to control the plane to heat the wingtips up, or you don't. But the difference in the thing with the X-15, and you start looking at what Virgin Galactic was doing with their vehicles, they couldn't even achieve in today's technology with modern engines and everything else. They could not reach 100,000 feet. And they spent more than 10 years trying to develop fuel systems to fly up. They launched that at 46,800 feet. Virgin Galactic launched the rocket to shoot up to 100,000 feet. People died trying to do that. They had difficulty flying at 46,000 feet in an aircraft. How come they have all of those problems and everybody else can do it? And in 1950s, you could fly much higher than that. They launched the X-15 off, a B-29 under the wing?
That's right, yeah.
So all of these things you take into an account, and then the X-15 basically had the same engine that was in, it's either the ascent or the descent stage of the LEM. Basically, it was the same engine.
3,500, that's right.
And the amount of fuel they had in there was just a little over 3 minutes of fuel. So wherever that B-29 launched it to, it had 3 minutes of fuel at full throttle to accelerate up to that height. And it's going up on an angle, of course. If it was capable of 200,000 feet, that would be one hell of a stunt in the 1950s. To have a company not being able to achieve that after more than Virgin Galactic, operating for nearly 20 years, could not achieve that same goal. They couldn't even reach 100,000 feet. That was going to be their tour thing. Like they said, take you to space and, you fly around, right? Well, actually, Virgin Galactic was going to take you to 100,000 feet and fly you across the U.S. and land again.
Well, they were going to try to, yeah. According to the Smithsonian, who we all believe is obviously knowledgeable about such matters, the maximum height of any X-15 plane was 67 miles, 354,200 feet. It was reached by Joe Walker when he was flying it, and not Neil Armstrong. So I think we've got a bit of a mismatch here, because if it's flying at 67 miles, it's way above the Karman line.
And then it would have to have heat shields to re-enter.
They say it was testing a new ablative thermal protection material and a proposed design for hypersonic ramjet. I mean, this is back in the 1950s. So they obviously knew they needed ablative material, but they don't say what it is. Obviously, that was what was glowing red when you watched it.
That stuff works better than anything they got out today.
They lost the formula, haven't they?
They'd have to have a completely different hull structure to travel into space with.
Yes, they seem to be having a lot of problems with their heat shields. And also, there's another anomaly here to do with the space shuttle specifically, or the space station. Whenever it enters the South Atlantic anomaly, which guess what is over the South Atlantic, near the coast of Brazil, they have to close all their computers down or they'll get fried because they're within the radiation of the inner Van Allen belts, we're told. Well, if radiation doesn't damage equipment...
You're getting a higher concentration at the poles. Like everybody says, oh, there's a hole there, and there's not. It's actually a higher concentration.
Yeah.
And you're going to have tremendous aurora borealis occurring during that area.
Yeah, you will. Yeah. Well, aurora australis, they call it in the south.
I've seen pictures of it where it's very red in the sky.
Oh, yeah, it is. Yeah. Certainly quite effective.
There must be a positive and negative to the poles then.
Well, it's like any magnet. Earth is basically a giant magnet.
Got a positive and a negative side to it.
So you've got the rays coming out of the North Pole, going around to the South Pole. You got that. So you've got magnetic fields around Earth. That's what protects us. So all this idea about radiation, there's plenty of radiation in space. Space is full of it, but Earth is protected, fortunately, or we'd have real trouble.
Yes, that is an anomaly in itself. The Earth, as far as space goes, is just the tiniest little speck of dust.
Yeah, tiny.
We're living on it, and we believe that it's a very large living source of material for us that we can draw from endlessly. Yeah. And it's not, it's finite.
Yeah, it is.
When they're looking for other signs of life, it's one of the reasons that space travel has such a calling to it, looking for something else like ourselves, something we can identify with, and we can't find it anywhere. Then you realize how powerful the universe actually is, or we can't imagine how powerful the universe is.
No, we can't.
And we are being protected from that, and we think we can go travel in it.
The video I put out yesterday, in the Apollo 16 footage, we can see that the side that they come down the ladder in is in the shade. But then when you look at the video, the astronaut's walking through the shade. As a matter of fact, he's in the shade and he's lit up even more.
Oh, they had those little spotlights on them.
But then when you look at the still image, it's all black there. He's in the umbra of this shadow here. So how can he be lit up in the video when he's walking right in the shadow? He's right in the shadow, right at the stairs, and his whole body's lit up.
The lighting crew on the set did a very good job.
They kept it well illuminated.
There's skilled professionals that are there on a movie set to make sure that the lighting is correct for the image they want to capture. So they're taking artistic license in creating that image for you and I to see, but it's not realistic.
I mean, it's noticeable that even when NVIDIA tried to recreate Aldrin coming down the ladder picture, they failed to increase the illumination in the hatch area, which in the official photograph is very well illuminated, very well lit up. In the NVIDIA recreation, they forgot about it.
They focused on Buzz solely. That was a response to what people said about Buzz being so well lit up in the shade there.
Yep.
And they also missed the fact that the sun that they artificially injected in there is a reproduction of what's in the photograph. And what's in the photograph is the diffusion of light through an atmosphere. And they recreated that in the NVIDIA image.
I would like to show you something here, Marcus. This is funny because This is Apollo 16 here. Now I'm going to show you something here. This is quite something. Now, there's the rover. Now, here's the guy. This is in shade. Huh?
There's sunlight on him the whole time. There's the shade out over the ladder. He's running right in front of the ladder right there.
Yeah, he is. He's fully illuminated the whole time he goes in there. Extraordinary.
It must have been almost lunchtime on the set there because it's about noon.
So what I'm doing is I'm comparing these LEMs here. We're looking at the light overhead, for example. Here, look at the light right overhead.
Look at the shadow under the rover.
Well, where is it here? Okay, now it's under the rover.
That's 16. You can tell it's 16 because of all the paint falling off the vehicle. There, you see it's all flaking off the top part of the vehicle there. That's why they had to blow that one up when they did the ascent, and then they had to repanel it and repaint it for Apollo 7.
But how can you be lit up when you're inside of this shadow here?
Well, it's dark in that one, isn't it? The ladder's kind of darkened down. The leg goes right off black.
Yeah, well, here it is here. This is the video of it.
Well, there's direct sunlight right on top of his helmet the whole time through there, isn't there?
And it's amazing how you can see the stairs. I can count every one of those rungs. Look at them. 1, 2, 3, 4, 5, 6. They're all lit up right down to the bottom.
Yeah, you can see where the shadow is. It's actually, there's sunlight hitting quadrant 4 with the equipment open there, right? You can see the light shining on it there with it open. That's how vertical it is.
There's 16.
Yep.
Yeah, well, it's not vertical anymore, is it?
No, it's not.
This is a little ridge, but still the shadow's coming out this way. Yeah, anyway, it's just crazy stuff, you know.
Yeah, well, it's high noon there.
Just going to say that the shadow length would be at least 50 or 60 foot coming out from the LEM. And seeing as the LEM is at least 20 foot high, it would be casting a shadow. And there's no way that he could walk, even if he was further away from the lander than he appears to be. He'd still be in the shadow. This is the point. Anybody who says, well, he's just walking further away, he'd be in the sunlight. No, he wouldn't. He would be in the shadow of the lunar lander because they always landed it with the sun behind them so they could see what was coming when they landed. All the landers, when they got onto the lunar surface, allegedly, the ladder was always in shadow because that 2 triangular windows above them was what they looked out of. Remember how Neil Armstrong had to fly it himself so he didn't land on the boulders? That was the story. And because he didn't land in the place they thought he would land in, Mike Collins couldn't take the pictures of him on the surface. There's no image of Apollo 11 on the lunar surface, even though Collins has been orbiting above him for 24 hours. You'd think he'd poke his camera through the window and take a picture of him. I mean, it's very easy to see the lander, apparently.
There's the sun angles. Apollo 16 is 22 degrees to 45 degrees.
Right. Well, that would cast a long shadow, a very long shadow.
Well, at 45 degrees, the sun angle of the LEM should be equal to the height of the LEM,
Yeah,
25 feet.
Yeah, I mean, look at these. The lower the degrees, the longer the shadow's going to be.
Yep.
Yeah.
We did a video with that before with the calculator for the distances.
Yeah.
We've already covered those sun angles, but yeah, they just keep popping up, don't they?
Yeah, they keep showing themselves. Hollywood likes to commemorate its achievement.
Neil Armstrong was their front man. Just like in a band, the front man is the one who gets all of the credit, the performance. You don't see the drummer or the bass guitarist. You don't see those guys getting much credit, but you certainly see the front man getting all the credit. Well, Neil Armstrong was that man, because every time there was a press conference or every time that the press went up to ask questions, they always went to Neil first. Buzz Aldrin wasn't as likable as Neil was. Neil seemed to have that American look. He was the epitome of the American dream.
Yeah, he had that boyish face about him, and he's very professional in his mannerisms and everything else.
Yeah, he was. Almost like he'd been trained.
Exactly.
Another thing some of the subscribers were bringing out was that, have you guys noticed that there's 2 television sets that are in front of them? In other words, there's monitors that those 3 are reading off of in that desk at that press conference. Why would you need text coming across the monitors to tell you what to say when you've supposedly been there? Did the technicians, did they know what it looks like? No, they weren't there. But these guys were supposed to be there.
Just shows that the script was written for them from day one.
Exactly, from day one.
They had to follow the script because then it would fit in with everything else they'd planned for. It was a brilliant production, as I've described it many times. A brilliantly executed propaganda exercise.
Well, they got away with it for this many years.
Yeah, they have. Yeah.
But they're not going to continue to get away with it.
Not anymore, because we need space travel to become real, not fictional. It's time to stop the ridiculous performance. I mean, you see what happened with Starliner recently. It got stuck up on the space station, which is real, by the way, before anybody says anything. It got stuck there, and the reason we're told that those thrusters on Starliner failed was because they hadn't taken into account the lack of gravity. What?
They're just figuring that out now?
Yeah, that was the explanation I saw just 2 days ago when it was stuck onto the space station. There wasn't enough gravity. Oh, come on, guys. You know, there's less gravity in space than there is here on Earth. And you dock it alongside the space station, which is orbiting Earth pretty fast. Every hour and a half it goes around once. So it equals out the gravity. Don't you know what you're doing, Boeing, who made the thing? Boeing also made the Saturn V rocket and collaborated with General Motors on the construction of the Lunar rover. You'd think Boeing would know what they're doing by now in space. Obviously not.
No, it's like their first day, isn't it? And there again, they're having problems with the helium tanks.
You'd think they know how to make a helium tank now, wouldn't they? They've been doing it for 60 years.
And there's the same thing. They've been doing the same thing over and over again for 60 years. They can't get past the penalty for the weight of the fuel alone.
Yeah.
And yet they continue to keep launching rockets with 32, 33 rockets underneath the thing. It weighs so much with the amount of fuel that they need to consume that it can't even make it to space. You would think a computer on today's standard could do the calculations to figure out where the maximum payload is, and when you make it bigger, your payload is reduced. That was already done in the 60s when they were designing the rockets there. If you made it big enough, you don't have any payload left because the fuel's going to consume everything to get you off the ground.
And also, don't forget that back in the 60s, when they were designing all this Apollo stuff, they were using slide rules.
Yeah, they work better.
Yeah, not computers. And just a piece of trivia here, Wernher von Braun and Sergei Korolev, the head of the Russian space program, were using the same make of slide rule made in Germany. And if anybody listening does not know what a slide rule is, check it out. Just put slide rule, you'll get a picture of it. Basically a mechanical computer, similar to an abacus in the way it works, which just shows that slide rule was considered to be a very good calculating device for scientific calculations. That's what it does. It does.